Okay guys, welcome to our Unit 4 test review. We are going to cover number 19 and 20. In case you didn't know, your voice might be on this video. Alright, let's look at number 19, okay? You guys are going to find linear equation as well as your quadratic equation. So let's go and review a little bit how to enter your data. Alright. So, notice you are not graphing and you do not have to go and figure out what kind of regression you're going to have. So you actually do not have to turn on your stat plot. The only time you want to turn on your stat plot is if you are going to be trying to figure out what kind of regression you have. So that will be down here, okay? So I'm going to go ahead and turn this off. So if you just go to stat plot and you turn it off. Now I want to enter my data, and here is my data. Your x1, your x will go into the L1, and your y will go into your L2. So if you hit stat and hit edit, this is where you will enter all your information. If you go to L2 and you hit clear, it will clear everything under L2. Go to L1 and hit clear, and it will clear everything under L1. If you do not have an L1 and an L2 right here, what you do is you hit stat. You see where it says setup editor? If you will hit 5 and enter, it will correct your L1 and L2 for you. Because you can go delete this, you can go and make names for it. That's something you might want to do later on when you get to upper math, okay? But for right now, we're just going to keep it as L1 and L2. So here's our x value. I like to enter mine straight down the x value. 1, 2, 5, 6, 8, 9, and 10. Okay? Right click over. Your y is going to be your L2 value, 27, 28, 31, 32, 35, 37, and 38. Just make sure that for every x value, you have a y value, okay? Now, I'm finished with that, and my first regression, it says linear. So I don't even have to go and figure out, hey, is this a linear, is this a quadratic? I'm telling you what I want. So to calculate your equation for linear, you hit stat, right-click to calc. You see where it says linear? Number 4. There is another linear down here as well. These are exactly the same thing, except this one puts it in mx plus b form, which is you're more familiar with, your slope, your x plus your y-intercept. Whereas this one gives you your y-intercept first. It doesn't matter which one you use. I prefer the 4 because that's what you're used to, okay? So your L1 goes here for your x, L2 goes here for your y, frequency list, which you've already done. Now, if you notice, you're not graphing this, so you actually do not have to save it. If you hit alpha trace, you're going to save it. But you don't have to do that because you are not graphing right here. So I'm going to just go ahead and calculate, okay? So here's my linear, ax plus b, which is your slope plus your x times your x plus b. Your a goes right here, and your b goes right here. You are looking at the r square. Not the r square. The r is a residual. So go ahead and write your equation. Okay. All right, let me see if I have it. Remember, an equation has an equal sign. You must write that y equal. And I'm just going to write what I see. 1.24, just go about 2-3 decimal places. X plus your b, which is 25.33. Okay? So there I have my linear. My regression, you can write it as 0.986, or you can write it as 98.6%. A percent is 2 zeros, 2 decimal places. So there I have my linear. Next one, it says, hey, go find me my quadratic. If you will look, you've already entered your data, so you don't have to enter it again. So hit stat, right-click to calc, and here's your quadratic, number 5. Number 7 is not a quadratic. Number 7 is a quartic, x to the 4th. So the quadratic, I'm going to hit number 5, Same thing. Do not have to store it because you're not graphing, and just hit calculate, okay? Copy these numbers down, replacing your A, B, and your C. So I have y equal, it is an equation, 0.053x squared plus 0.66x plus 26.35. Order of highest to lowest. Your R square is 99.7%. Okay? So all you're doing right there is looking for an equation. All right, the next part says, use the quadratic model to answer the following. Well, notice how we did not graph this. So you have to go back and graph it this time in order for you to find your value. So if you hit Stat, right click, do it all over again, except when you get to right here, hit Alpha Trace. I want to store it in Y1, so hit Enter. Okay? All that does is it puts it in this Y1 right here, so you don't have to write all those numbers. And now you can kind of graph and see what the graph looks like. Now, notice I see nothing on my graph. But if I hit Stat, hang on before I show you something. Notice I have a bunch of numbers. This is from a previous person who did other things. This is probably an ATM class. But if you'll hit Zoom 6, okay, that means this is negative 10, 10, negative 10, and 10. Notice I don't see anything still. Go back to this top part. Go to your window. Here's your x. Your lowest x is a 1. Your highest x is a 10. So I have negative 10 to 10, which is fine. I actually like mine a little higher and go a little below. Look at your y minimum. Your lowest y is a 27, which is a negative 10. Your highest y is a 38, and this one has 10. This is the part where you might want to change. I'm going to keep my negative 10, but I'm going to go higher than 38, because right now the high is a 10. You want to go higher, okay? So let's go and put 50. Think a moment. You want your x to be 24. You might want to go even higher, okay? So I'm going to actually put 100. When I do that, I want to change my scale to a 10 because I don't want a bunch of little tick marks. And now you should be able to see your graph. So there's your graph, and there's your quadratic. See how it has the shape of a parabola, okay? All right. Now it says, use that model to answer the following questions. What is your y value when x is 24? Two different ways you can do this. You can hit second table and scroll down until you see 24. That's one way to do it, okay? So when x is 24, y is 72.695. Write your answer as an ordered pair. That's one way you can do it. Another way is you can hit second calculate. See where it says value. Value is your x. And I'm going to type in 24. This one goes directly to 24 without having to scroll. Two different ways. Oops. Notice it says invalid. Let me tell you why it's invalid. Invalid because your number wasn't high enough. Let me see. My max is only 12. See your x? Need to change that to a 25. If I cannot see it on my graph, it is not going to give it to you. So two different ways to do it. Hang on just a moment. All right. It was only at 12 at the time. Now it gives it to me. Okay? So when x is 24, y is 72.695. Same answer. Your window will play a factor. If you can't see it on this window, you're not going to be able to find it if you use second calc. All right. Now it says find the x value when your y is 46. Okay? So notice you have a graph right here. Check your window. Your y is 46. Is 46 between negative 10 and 100? Absolutely. So now all you have to do is go to y2, make it a straight line across at 46, and you want to find the intersection of where they're crossing right there, okay? So notice that's an intersection. If you hit second calculate, there's an intersection on number 5. Hit enter. Never use the up and down. Always use your left and right. First curve, enter. Second curve, you want to be to the right of this point. Not up and down, left and right, please. See how you have the left boundary and the right boundary? Okay? At 46, what is your x value? 14.01. And there you have your two solutions. There's number 19. All right, number 20. Okay, now this is the application part. This is your modeling. It says the table below lists the number of cell phone subscribers in millions. Keep that in mind. For the years 1991 to 2001. Now, right here, you're going to have to go and find the things I'm asking of you. This is where you might want to turn on your stat plot, okay? So, let's clear this one. Let's clear this one so you don't accidentally use it twice. Let's go ahead and enter our data, but before you do, go to your stat plot. It's in blue. Go ahead and turn that on. You want to pick the plot points, and you can pick any one of these that you like. I like the box. Make sure this says L1 and that says L2. We're going to enter our data, so hit Stat, Edit. Let's clear that one. Clear the L1 also, and let's go ahead and enter our data. Okay, why don't you guys enter the data with me? 1991, 1992, 1993, 1994, 1995, 1996, 1997, 1998, 1999. Okay. Let me move this up a little bit. 2000, 2001. Make sure your numbers are correct. If you're off by one number, it will mess up the whole equation because you are dealing with data. Okay. Go to your y value, enter your data. 7.6, 11, 16, 24.1, 33.8, 44, 55.3, 69.2, 86, 109.5, 128.4. For every x, you must have a y. Make sure your numbers are correct in comparison to your data. Okay. All right. Now, you have entered the x and y values into your calculator. Very good. Next one, it says provide a linear model of the data and the R square. So basically, you're looking for an equation. So hit Stat, right-click over, Linear Regression, number 4. I am going to go ahead and save this one just in case. I have to do something with it. Okay? All right. Part B, write the information you found. Y equal 11.997 x minus 23893.38. Okay? And your R squared value is 94.7%. There you go. And I just got all that information from my calculator. C says, use the linear model to predict the number of cell phone subscribers in 2017. Now, if you look, we only went to 2001. This is our X value. That's your year. So to change it, go to your window, okay? If you hit zoom 9, you guys see how that's an increase? It's almost an exponential, but it's a parabola. But I'm going to go to my window, and the reason I did zoom 9 is I didn't have to go enter all this information. Notice your X value is only 2002, and you're trying to find 2017. So go ahead and change that to 2020, okay? Go a little higher than the number. You can put 2017. All right, it says use a linear model to predict the number of cell phone subscribers in 2017. Two different ways you can do it. You can hit second table, which you're going to have to go far, or you can hit second count and hit 1 and hit 2017. In 2017, let me write it right here, you are going to have 300, why does that not look right? Let me check. Okay, that looks fine. 0.11, okay, subscribers. Remember, this is in millions. This is not 305 people. This is 305 millions. Okay? It's 305,110,000. That's what that is. Okay? So that's not 305 people. All right. Now, so in 2017, they're going to have 305 million people subscribe, cell phone subscribers. Notice it kind of gone up. Part D says, provide a quadratic model of the data with the R² number. So now we're going to go to a quadratic. You do the same thing, except you hit stat. You don't even have to get rid of it. Go to quadratic, which is number 5. Go ahead and save it as well, and write your equation. So here's your quadratic. Y equal 1.00x squared plus, not plus, minus 3986.05x plus 396614.8.99, okay? And your R² value is 99.8. 99.9 if you round it correctly, percent. There you go. Quadratic. Highest degree must be a 2. All right, part E says, use the quadratic model to predict the number of cell phone subscribers in 2017. Well, before you do that, check your window. See how it says still 2020? So you can just use your second calc, hit value. Oh, look at this one. This one hits almost every point. It's more quadratic than it is linear. And I'm going to put 2017. In 2017, there were 736,768,000 subscribers. Okay? That's a point. By the way, don't use a comma here and a comma here. Okay? Leave a little space instead. A tiny little space. But if you use a comma here and a comma here, how do you know which one's your X, which one's your Y? So don't use 2 commas. Just put a comma in this place, put a decimal if there's a decimal, but if it's 736,000, for example, just leave a little space. Don't put commas and commas. That doesn't make sense, okay? It's kind of like putting a question mark and a period in the same sentence. That doesn't make sense. All right, which model better fits the data? Well, if you take a look at your information, do you notice how this one has a higher correlation coefficient? And it's hitting almost every point. And if you really think about it, cell phones took off in the early 90s. Here, everybody has them. Back in the 90s, not everybody had them. So I would say the quadratic fits the better model. Okay? Why? Better R² value, which is your correlation. I can't spell correlation. Coefficient. C-O-R-E-L-A-T. Okay, 1 L. Is it 1 L or 2? I have to double check on that. All right. G. Use the quadratic model to predict the number of years since 1991 in which the number of cell phone subscribers was 175 million. Well, you have your graph, your quadratic, and you're trying to find out where that crossing is at 175. Just like we did before, okay? At 175 million, you want to know what year that's going to be. So if you hit Y2, type in 175, okay? Check your window. Notice your Y max only goes to 148. You want to go a little higher. I'm going to go ahead and hit 200, and then graph. And that's what we want to know. At this point right here, what is your X value? Okay? So we're going to try to find that intersection. If you hit second calc, see where it says intersection? I want to be to the left of it. This kind of tells you where it is right now. Okay, enter. Go to the right of it. enter. So at 175, what year is that? That's 2002, almost 2003. Actually, it's a little bit more than that because there's 12 months. There's not 10 months in a year. All right, so in 2002, that's when they're going to hit 175 million subscribers. And there's your application part. Okay. All right, good luck tomorrow. I will do the video for the 3rd page, and I will email that to you later today. Any questions? All right.